Okay, hello everyone. Welcome to the channel Master the Codes. And today we are taking the fifth part of the graph series tutorial, and that is cycle detection algorithm. Right, we are going to take cycle detection algorithm today as explained in the previous video. And this series is for all those preparing for placements, coding interviews, or who have just reached out to the graphs and want to gain more experience in data structures. So to keep the content growing and staying notified, please like, share, subscribe to the channel for more notifications and related content. So without wasting time, let us get started. Okay, so today we are gonna take the cycle detection algorithm as a topic for today. And now first let me tell you what is indeed cycle detection algorithm. So for that I'll create a graph like this. Okay, so I have created a graph and I'm numbering these nodes as 1 2 3 4 and 5. Now what is actually a cycle? If you are starting from node 1 and by following a sequence or a series of path, you are reaching a node that has been visited already. Like you can see, this node 1 has already been visited. Right, you are starting from 1, then you are going 2, you are going 3, you are going 4, and you are going 5, and after 5 you are again coming to 1, and the cycle will repeat itself. So you can see 1 is occurring more than one time. Like, yeah, you are reaching 1 multiple times. So you are reaching a starting node multiple times. So that is a cycle. Also, there can be multiple variations in cycle. Like if you have a cycle, let's say you have a graph like this, right? Now the entire graph is not a cycle, but only this particular portion is the cycle, the subgraph, right? This subgraph is the cycle that we want. So to detect it, how can we detect? We have learned about two traversal algorithms. One is DFS and other one is BFS. I have told you DFS is preferred in cycle detection. I'll tell you why. You will get to know about it in the later part of the video. But first, this is what a cycle is all about. Also, just a simple question. If I say something like this, is this a cycle? No, actually this is not a cycle, because you can see it is an undirected graph. This graph does not have directions like this, right? So if you go from 1 to 2, it means you are going from 2 to 1 also. It means one and the same thing. So it is not a cycle, right? If you merge these two edges, you can directly create an edge like this, right? You are going from 1 to 2 and you can go from 2 to 1. So this type of edge construction is not possible in graphs. Rather, a graph must contain 3 nodes at least to have a cycle. Then only you can say there is a cycle. This particular point is the most important. A graph must contain at least more than 3 nodes to have a cycle. Now, if I have a graph, let's say like this, yeah, let's say you have a graph like this and you are starting from node 1, right? And you are going performing DFS. Now what will the algorithm look like? The algorithm is like this. But before starting any algorithm and graph, you need to create the adjacency list. So the adjacency list would be 1 is connected to node 2 and 6, 2 is connected to 1 and 3, 3 is connected to 2 and 4, 4 is connected to 3 and 5, 5 is connected to 4, 6 and 7, 7 is connected to 5 and 8, 6 is connected to 1 and 5, and 8 is connected to 7. This is what we call an adjacency list, right? This is the adjacency list. And if you don't know what is adjacency list, please have a look at the first video of the tutorial where I had explained about all the things required to create an adjacency list. Right now we are performing DFS over here. The main thing is we are performing DFS over here. So if you remember the algorithm, if you don't know what is DFS, check out the fourth video. In the fourth video I have explained what is DFS, and there you can check it out. Now we are performing DFS and a start node is 1. We will create a stack, or rather the call would be like this: DFS starting from node 1. Now what are the neighbors of node 1? Our neighbors are 2 and 6, and there are 8 nodes, so let me create the visited array as well. This is the visited array where I am naming 1, 2, 3, 4, 5, 6, 7 and 8, and I have marked them currently as false. And now from DFS1 we can move to either 2 or 6, it doesn't matter. We are moving to 2. Now we have reached over here. Now what are the neighbors of 2? Now in the algorithm you have seen we are visiting the source node more than one time. Here you have seen, right? Or even if we are not visiting the source node, we are visiting nodes multiple times. Now if you look at it, 2 has a neighbor of 1. 2 has a neighbor of 1, right? It has neighbor which is already visited. So does this create a cycle? What are your intuitions? No, this will not create a cycle. Like I told you, 1 and 2 will not create a cycle, right? Because 1 and 2, if you reach from 1 to 2 and you are again reaching from 2 to 1, it means you are jumping just one step back. You are actually not going forward, right? You are not going forward, you are just going one step back. That is, from child you are going to the parent, which is already visited. And of course if you are reaching to the child, then means the parent is clearly visited. If you are coming over here, this is part is already checked, then only you can come to 2, right? So that is the thing. Whenever you are like going from higher level to a lower level, the higher level is always checked, then only you can jump to the lower level in the recursion. Therefore we will only mark the points as cycle which do not have their parents visited. Now, what do I mean by this? If you have like this particular node 2, and somehow after n operations you again come back to 2, right? After n operations you again come back to 2, then you can call it as a cycle. Otherwise you cannot call it as a cycle. The node that you are checking that is visited, if you have found a visited node, then it should not be a parent. This is the main criteria. If a visited node is found, then it should not be a parent. Right? If the visited node is found, then it should not be a parent. Now, looking at this particular point, keeping this particular point in mind, it is an important point, right? It is an important point. Please do not forget it. It is important. Now, keeping this in mind, let's see. Node 1 is checked or visited. Now we are coming to node 2. Node 2 has parents 1 and 3, and 1 is visited, right? So we have found a visited node, but this visited node 1 is the parent of 2, right? So if I recreate this DFS call, what it will look like? It will look like DFS of 1 with parent of -1. Then what is happening? DFS of 2 with parent of 1, right? This is node 2 and node 2 has a parent of 1. Then we have DFS of 3 with parent of 2. Then we have DFS of 4 with parent of 3. We have DFS of 5 with parent of 4, right? We are here and the parent is 4. Then from 5 we can go to 7, or we can go to 6. Let's first go to 7. DFS of 7 and the parent is 5, right? Then DFS of 8 and parent is 7. Now the call will end over here. The branch will end. One branch will end. Now why the branch will end? Because parent of 8 is 7 and we have 7 is visited, right? I forgot to mark the nodes. These nodes are visited. 7 is parent and it is visited. You do not have anything else to check. So branch will end. Now, what is our next branch? The next branch is 6. DFS of 6, 5, right? First we took this branch, now we are taking this branch. This is what we took as first, and now this is what we are taking as second. Now DFS of 6 and 5. Now we are getting DFS of 1 and 6. Now 1, you can see 1 is already marked over here, and yeah, 1 is marked over here. At this point 1 is marked, and the parent of 1 is 6, right? That is not yet marked. As you can see, 6 is not yet visited. So at point 1 you will get a cycle. At this particular point, you will get a cycle, because after this entire operation, when you're coming to this particular point, coming to DFS of 1 with parent of 6, you will find 1 as visited, and it is not a parent right now, right? Because if it would have been 1 comma 1, then 1 is over here, right? And it is a parent, but this time 1 is at the first position, it is not at the second position. If speaking plainly in terms of logic, I'm not speaking in terms of recursion right now, I'm speaking in terms of simple logic. 1 all is coming on the first side, on the first time. Yep, out of all the both parameters, 1 is coming for the first time, then we are getting a 6. So any time, if I say any time I get a visited node at first index, then I have a cycle. This is also one deduction which you can do. In any case, if you see, up till now, at no place we have found a visited node. But at this particular point, we found 1 as the visited node, and that was at the first index. That means 1 was not the parent. It satisfies this condition. It is not a parent and is a visited node. Then we will return true. And all these steps will return true, and in the end we will get true. So that is how DFS is used to detect cycles. Now, if I draw the same, you can say, tree for BFS, what I will get, or rather I'll try to draw a smaller tree, and yeah, and now again I have 1 as the starting node, and now I am using BFS for this time. So I will again create an array. My array is of nodes 1, 2, 3, 4, 5, 6 and 7, and they are currently marked as false, right? Now if you try to detect cycle in a BFS, it is a bit tedious and difficult, because here as well you have to, maintain the parent property. Here as well, in the call you will get 1 and pass the parent as -1. Now BFS does not go branch wise, it goes depth wise. You will explore its neighbors. So what you will do, you will do BFS of 2 and BFS of 6 at the same time, and 2 has the parent of 1 and 6 has the parent of 1. Then from 6 you will go to BFS of 5, which has parent of 6, and BFS of 3, which has a parent of 2. Then from 5 you have again 2 options. Here please have a look. At 5 again you have 2 options, which is BFS of 4, which has a parent of 5, and BFS of 7, which has a parent of 5, right? It has again 2 options, and from here you are going to BFS of 4, which has a parent of 3. And now from 4 if you have a look, you have BFS of 3 which has a parent of 4. Now, at this particular point, you have reached 4, right? If you start from here, you have reached 4. And now, from here as well, we have reached 4. So, two paths, two paths are reaching the same node, right? Two paths are reaching the same node. So that marks a cycle. That means we have found a cycle and all the nodes have been visited by now. Because at this particular point, I have this node 4 and that is aligned with node 4 over here that is visited. So here I am checking the first index and here I am checking the second index. Yep. So, but the main problem comes over here. Every time there is a branching, you need to maintain this. You need to maintain the parents of every branch. You need to maintain the parents of every branch. Now, it depends whether you store them in a list, in a queue, in an array, but that means there is extra work you need to do if you are using BFS, because of which DFS is better than BFS. For cycle detection, I'm not saying for all cases, but for cycle detection, DFS is better than BFS. Yep. So that's all for today. Now we are going to jump into the codes. I will give you the code for DFS only because since that is the code you need to work upon. You will rarely be asked the codes about DFS, but if you need, I can give you that as well. Just put it down in the comments. Now, before we move to the implementation part, please like, share, and subscribe to the channel and hit the bell icon for more notifications. And now we are gonna move to the finding the cycles. I'll create two graphs which are separate, which has a cycle and another which do not have a cycle, and run the DFS algorithm in it, right? And I'll show you how it works. Okay, so here is the code. First is the scanner for taking the input. I created the graph using integer and this list as the two key and value pairs. Now you know how to create an adjacency list, right? If you do not know, please check out the first video of mine. I've explained how to create an adjacency list because if you're solving a graph problem, you will be required to create an adjacency list in it. Then I'm taking the number of edges and the number of vertices in it. N denotes the vertices and M denotes the edges. Then I'm simply initializing this array. I am initializing the key values, or the keys, and then I'm taking edge. Now I'm taking edge in a format like 1 space 2. That means 1 is connected to 2 and 2 is connected to 1, like this, as you can see over here. Yeah. So the graph will look like this, containing a cycle. Then I'm adding the nodes into the graph, like N1 is connecting to N2 and N2 is connecting to N1. And I'm calling this recursive function of detect cycle. Now, in this detect cycle, what all things I need? Now, if you check out the few minutes before, I need a node, I need the parent, I need an adjacency list named graph, and I need a visited array, right? Now, first thing is I'll mark the current node as visited. I will check each neighbor of the given node. And if the neighbor is not visited, like you can see, not the exclamation mark over here. If the neighbor is not visited, this is an important, this is an important code that you need to learn or memorize. If it is not visited, I will recursively run this function. Now this node is replaced with neighbor, the next node, and the parent becomes the current node. Like earlier, the node was, you can say, in starting, the node was 1, DFS was 1, comma, -1, and now it changed to DFS of 2, comma, 1, and so on. It will change, right? Then I'm running this particular piece of code. If the neighbor is visited, it is also an important code that you need to learn or mug up. That depends upon your way of learning things because it is quite important. If neighbor is not the parent, right? If you are not going backwards, you are not going backward, you are checking forward. If the forward node is visited, right? If you are checking the backward node, that means you are backtracking. You are not backtracking, you are moving forward. If the forward node you found that is visited, that means you have completed a cycle and returning true. And after all these recursion codes, if you do not find any cycle, you will simply return false. That is how you write a detect cycle algorithm for a graph, right? And a tree in, you do not need to write this detect cycle algorithm for a tree because tree does not contain any, you can say, edge cycles or loops. Tree does not contain any cycle or a loop. Now, if I run this particular command or this piece of code, copy this test case. Now, what this test case means is number of nodes are 4 and number of edges are 4. And the first edge connects 1 and 2, the second edge connects 2 and 3, the third edge connects 3 and 4, and the fourth edge connects 4 and 1. And I'm getting true. Yes, I have found a cycle. And if I run this particular code, if I run this particular code, I have copied it. Let's run it again. And if I run this particular code, I'll get a false because I have not found a cycle in it. I'll share this code, the link, and the GitHub in the and the notes as well in the link below the description. Please have a look at them. If you find any problem in it, let me know and I'll resolve it. Please tell all the key suggestions you want to give in the comment section. And do not forget to like, share, subscribe to the channel. Thank you everyone, and we'll meet again in the next video. Yeah.